Jai Shri Gurudev. Dear student, welcome to session 6 of module 2. So in this session, we will solve few more problems on block diagrams and signal flow graph representation. So in the previous session, you have learned about Mason's rule, which is used to solve the given signal flow graph, and we had taken few examples and we saw what is the procedure that is followed to evaluate the transfer function for the given signal flow graph. This is the outline of my session. So in today's session, we will discuss problems on block diagram and signal flow graph, and you will learn here how to represent a given block diagram in the form of a signal flow graph, and then we will apply Mason's rule to evaluate the transfer function for the signal flow graph, which is generated using the given block diagram. So let's take one example here. So this is the block diagram given to us. Now your task is to represent this block diagram using the signal flow graph. So please do observe here. I have input as R of S, error signal is here E of S, and output as C of H. So here one thing what you need to remember is each of the summing point here, okay, and the takeoff point is considered to be a node, and input is also considered as one node and output is considered as the another node. So summing point and your takeoff points are represented by nodes, and the connection that we are going to give here, these are called as your branches. Okay, so let's try to represent this block diagram using the signal flow graph. So I'm first taking my input node, and then E of is another node, then x1 is one node, x2 is another node, and C of S is another node. So this is what I told you. So x1 is one summing point, x2 is another summing point, which is represented by a node here. Y1 is one summing point, y2 is another summing point, so I have represented that with the two nodes. E of S is one takeoff point or summing point, that is represented with a node, and this is your output from where the feedback is taken, so that should be represented by a node, and input is represented with an input node. Now once this is done, the next step is you need to connect this using the branches. So please do observe. So I am connecting R with E and C with E of S. This is the feedback what we have that is connected, and then see the connections properly. So if you do not have any gain, okay, so here directly I am taking it, so it is represented by 1. So here you have the feedbacks, but here since it is minus, I am taking the gain to be -1 here. So similarly connect this with the box is having a gain as G1, so that is represented with a branch with a forward path gain as G1, and then this is represented by 1. So direction of the arrows you must give properly along with the sign, and then G2, then you have one more branch from Y1 to C of S, so connected. So this is the signal flow graph representation that we have got for the given block diagram. So once you represent the signal flow graph like this, the next step is you have to apply the Mason's rule for this particular signal flow graph, and you have to evaluate the transfer function. That we will see in the next slide. Okay, so same signal flow graph I have taken. So we will evaluate the loops. Okay, so how many loops do I have here? Totally I am able to get 7 loops here. Okay, so let's see. So this is one loop, this is another direct loop what I have, G2, then G1 minus 1, G2 1. So I'm starting from here, G1 minus 1, okay, then G2 1. So this becomes another loop, okay, this one 8 like structure, okay, right. Now similarly you have G1 minus 1, 1 into 1, that is from here if I start, right. So I'll write it here in green color. So you will start like this, you will go like this, you will come like this, and you will reach here. Okay, this becomes one loop. Similarly you have another loop in the same way. You will start like this, in the reverse direction you will go like this, you will come like this, and this becomes another loop. Like this, totally 7 loops I am able to evaluate for this signal flow graph. So G1 into minus 1, so it is minus G1 minus G2 minus G1 into G2 plus G1, so minus G1 into G2 minus G2 minus G1 into G2. So 7 loops. Coming to 2 non-touching loops, we have 3 non-touching loop which does not touch each other, that is G1 into G2, that is these two, they doesn't touch each other. Similarly, we have another 2 loops which doesn't touch each other. Okay, so these 2 loops, they are not touching each other, right? These 2 loops are not touching each other, so that is represented here. And coming to the forward paths, we have 4 forward paths. So one is, this is one forward path, you have another forward path like this, and you have one forward path like this. Okay, so one more forward path in the another direction. So P1, P2, P3, P4, and delta 1, delta 2, delta 3, delta 4 is nothing but equal to 1 plus G2, delta 2 is 1, delta 3 is 1 plus G1, and delta 4 is 1. And delta value, when you evaluate, you are going to get it as equal to 1 plus 2 G2 plus 4 G1 into G2. Okay, so try to evaluate the forward paths in a proper way, and when you are finding out your delta 1, delta 2 and delta 3, you have to eliminate all the loops which touch that particular forward path. So after evaluating all these things, the last step is you have to include all these values using the Mason's gain formula, which is taken as E of S by R of S is equal to summation Pk delta K divided by delta. So we had 4 forward paths, so it is P1 delta 1 plus P2 delta 2 plus P3 delta 3 plus P4 delta 4 divided by delta. So when you replace all these values, you are going to get your C of S by R of S for this particular problem as equal to G2 minus G1 plus 2G1 into G2 divided by 1 plus 2G2 plus 4 into G1 into G2. So this is how you can simplify a given block diagram using the signal flow graph representation. So this is another example which is quoted. The task is here is determine the transfer function C of S by R of S for the block diagram below by using the signal flow graph technique. So as I told you, nodes you must write. So first you have your input node. Here you have one takeoff point. So this becomes my second node. This is my third node, fourth node, fifth node, sixth node and seventh node, followed by output node. So totally we have 1, 2, 3, 4, 5, 6, 7, 8 nodes. So first identify the number of nodes. Now then start connecting. So from here, from input node to this takeoff point, there is nothing, so it should be 1. So I have represented it as 1. So from this node to this node, there is nothing, so I have to represent the gain as equal to unity. From D to C, if you take, you have a gain as G1, so represent that with the forward path with gain as equal to G1. So from this node to this node, you have the gain as equal to G2, and from here to here you have the gain as G3, and from this takeoff point to this summing point you don't have anything, so take the gain as equal to 1, and from the summing point to the output node C there is nothing, so here again gain is 1. Now coming to loops, here this takeoff point is connected to this summing point with the negative feedback, so it is represented as minus H1. So the same thing is getting connected to this node, so here the gain should be represented, the feedback gain is taken as H1, and from here I have one feedback, that is one forward path which is going like this, so that is represented with a branch. Now once you construct your signal flow graph in a proper way, the next step is you have to find the number of forward paths, number of loops, number of non-touching loops, and then using the Mason's gain formula you have to evaluate the transfer function. Now coming to the forward path, so I'm starting like this, I'm directly going here from R to C. So the gain that comes here is G1, G2, G3. Now another forward path is directly I'm starting from here and I'm reaching my node like this. So the gain here is G4. So these two are taken as P1 and P2. So P1 is G1, G2, G3. P4 is just G4. Now coming to the number of loops. So as you can see here, one small loop is, this is G2 minus H1. This is one loop. Another loop I can have is this one. And one more loop is here, this one. I'll start from here. I'll come like this. So I have three loops, L1, L2, L3. So L1 is taken as minus G2 into H1. L2 is taken as G1, G2, H1. And L3 is taken as minus G1, G2, H2. Now coming to the non-touching loops. So here, since I have only three loops, all the loops they touch each other. So there are no non-touching loops. So delta is taken as 1 minus your loops L1, L2, L3. So it is G2, H1, G1, G2, H1 you have to add, and that is taken as your delta. And coming to the delta 1 and delta 2 value, all the loops they touch the first forward path. So you can observe here. And coming to second forward path, if you can observe, all the loops they does not touch this forward path. It's a separate forward path. So consider all the loops for your delta 2. So delta 2 is nothing but equal to your delta itself. Okay, so everything is included here in the form of a transfer function. So your transfer function is taken as P1 delta 1 plus P2 delta 2 divided by delta. So which is taken as G1, G2, G3 plus G4. Delta value itself we are taking. So G2, G4, H1 minus G1, G2, G4, H1 plus G1, G2, G3, H4, H2 divided by delta. So this is the transfer function what we have got for the given block diagram. So this is another example. In the similar way here also we are taking the nodes. So input node, summing point, so 3 nodes, 4th node, 5th node, 6th node, 7th node, 8th node, 9th node. So totally here I have totally how many nodes? Connect all the nodes here. So R, from here to here you have one summing point. So you can combine together these two summing points. Okay, and you can represent them using the signal flow graph representation which is given here. So this is another signal flow graph what we have written. So it is G1, G2, H1 is one loop, G2, G3, G4 is one forward path, H2 feedback is taken to this node, and you have one feedback which is represented with a unity gain as -1. Now we will try to find the loops and forward paths for this particular signal flow graph which we have written. So one forward path is you are starting from here and you are reaching the node C directly. Another forward path is you will start like this, you will go in this way. So one forward path P1 is coming across the gains G1, G2 and G3. Another forward path gain is G1 and G4. Now coming to loops, here we have one simple loop here. This is L1. Another loop is this one, L2, and one more loop is this one. Okay, now one more loop is I can take like this, take the second forward path, alright, and this becomes one more loop. So totally 1, 2, 3, 4 and 5 loops. One more loop is okay, this loop you have got. Another loop is, so you will start from this node G4 circle, the circle structure. This becomes your another loop. So totally you have got 5 loops with the gain as equal to G1, G2, H1, G2, G3, H2, minus G1, G2, G3, G4, H2 and minus G1, G4. So now using this, find the delta value, which is nothing but equal to 1 minus summation of all loops. So here there are no non-touching loops because all the loops they touch each other. So this is the delta value what I am going to get. Now we have two forward paths and all the loops they touch the forward path. So your delta 1 and delta 2 is taken as equal to 1. So finally the transfer function is given as equal to this. So combine all the values, put together, that becomes your transfer function. So C of S by R of S is equal to P1 delta 1 plus P2 delta 2 divided by delta. So let's take an electrical circuit and we'll see how to represent this using the signal flow graph. So first thing is, for the given electrical network you have to write your nodal equations. So you have to write the equations for your voltages. So V1 is taken as equal to here 1 by C of S into I1 of S plus I1 of S into R. Similarly, the output voltage V2 is taken as voltage across this resistance. So it is nothing but equal to current flowing through this is I1 into your resistance. So in terms of Laplace transform, we are writing it as equal to I1 of S into R. Okay, now cross multiplying the C of S here and simplifying for I1, this is the expression we are going to get. So similarly, the second equation what I am going to get is for V2. So now take the nodes for the current and the voltages. So V1 is my first node, that is input. I of S is my second node and V2 of S is my output node. Take the nodes like this. Then connect your branches like this. So V1 of S is the input, so it is getting multiplied with C1, so take that as your gain. And similarly from V2 you are supposed to take a feedback. Okay, it is taken as C of S here plus C of S here. So if you have plus here, it is since minus, you will take it as minus C of S, and then second equation is V2 of S is equal to I1 of S into R of S. This equation I am taking, so I am multiplying R here. So this is a simple flow graph what we have got for this electrical networks. In a similar way, you can write a signal flow graph representation for any given network by writing the node voltage equations and taking the Laplace transform for it. And similarly, if you have a mechanical system like this and if you want to write the signal flow graph for this, here also you have to write the equations for the force. So one equation in terms of Laplace transform is f of s is equal to m1 s square x1 plus k1 into x1 x2. The second equation is for your mass m2. So 0 equal to m2 s square x2 plus k1 x2 minus x1 plus k2 x2. This is my second equation. Now for these two equations we will be evaluating the signal flow graph. So combine the variables with common terms like this. So f2 k1 x2 is taken left side and the variable with x1 is combined together. So you'll get two equations in this way. Now there are three variables, that is x1 x2 and f. Okay, so we just require two nodes. Okay, right, for your x1 and x2, one node for f. So write the equation for x1 and x2 in terms of f and x1 x2 like this. Now one equation is 1 by a f plus k1 by a into x2 is equal to x1. So first input node, input is always 4, so that is taken as input node. The last displacement is x2, that is taken as your output. So from f1 to x1, from f to x, if you can take f is getting multiplied by 1 by a, that is taken as the gain, and you have x2 here. To arrive at x1 you will be taking that as a feedback and it is taken as k1 by a, and x1 is directly getting connected to x2 and it is getting multiplied by k1b, so it is taken as k1b. Right, now once this is done, you can find the transfer function. So we have one forward path and one loop, that's all. So your forward path is k1 by ab, feedback is k1 square by ab, and your delta is 1 minus p1 that is your loop 1, and your delta 1 is 1. So just replace all the values here, so that becomes your transfer function for the given mechanical network. Like this, by using the signal flow graph, we can represent a block diagram, we can represent an electrical circuit in the form of a signal flow graph, or we can represent a mechanical system in a signal flow graph like this, and we can find the transfer function very easily using the Mason's rule. So in today's session, we have learned how to represent a given block diagram in the form of a signal flow graph and how to simplify that signal flow graph using the rule. And then we had taken an example on an electrical network which is represented using the signal flow graph, and we have seen how to evaluate the transfer function for that given electrical network. And the last example is we have seen how a mechanical network is taken and how it is represented using the signal flow graph representation. So these three concepts you have learnt in today's session. So you will get one definite question on this. So block diagram will be given, or an electrical network would be given, or they might give a mechanical system like this, and they'll ask you to represent them using the signal flow graph, and you're supposed to evaluate the transfer function. So this topic is a definite question for 8 marks in the examination. In today's session, we have learned how to represent a block diagram using the signal flow graph, an electrical network using the signal flow graph, and mechanical system was also represented using the signal flow graph, and you have learned how to solve the signal flow graph using the Mason's rule. So these are your reference book from which the problems are taken. So if you want extra problems, you can refer the given books here. Thank you all. Have a nice day. Jai Shri Gurudev.